A subway car screeches into the station, packed and roaring. The moment a pair of headphones turns on, most of that noise simply vanishes. It is not muffled, not quieted, just gone, while the music underneath stays perfectly clear. No physical barrier got thicker, no seal got tighter. So how does a small pair of headphones erase a sound that is still physically happening all around you? The trick is not blocking sound, it is actively cancelling it with more sound. This seemingly counterintuitive concept, known as active noise control, or ANC, was first patented in 1936 by German inventor Paul Lueg, though the technology to make it practical would not emerge for decades. In the 1950s, Dr. Lawrence J. Fogel, a pioneer in human factors analysis, developed and patented systems for active noise cancellation specifically for helicopter and airplane cockpits, aiming to protect pilots' hearing and improve communication. Later in 1978, Dr. Amar Bose, founder of Bose Corporation, famously conceived of modern noise-cancelling headphones during a noisy flight from Zurich to Boston, frustrated that he could not enjoy his music over the roar of the plane's engines. His company would go on to release the first commercially available ANC aviation headset in 1989. Each ear cup in your headphones contains tiny microphones, typically micro-electromechanical systems, or MEMS microphones, constantly listening to the noise in your environment in real time. These microphones pick up that low rumbling engine, the roar of the train, or the persistent drone of an airplane cabin. The captured sound wave is then instantly fed to a sophisticated digital signal processor, or DSP chip, within the headphones. This processor analyzes the incoming sound wave's amplitude, frequency, and phase within microseconds. It then generates a second sound wave that is its exact mirror image, identical in shape but precisely 180 degrees out of phase, or flipped upside down. Sound itself is just a pressure wave consisting of alternating periods of compression and rarefaction in the air. When you take that original pattern of rising and falling air pressure and add its perfect mirror image to it, the compressions of one wave align with the rarefactions of the other. This phenomenon is called destructive interference. The two waves collide directly in the air, effectively cancelling each other out almost completely, much like adding a positive number and its exact negative equals 0. The headphone's tiny speaker then plays that inverted anti-noise wave at the exact same time the real noise reaches your ear. This collision happens right next to your eardrum, destructively interfering before your ear ever fully registers the original sound. This active cancellation works extremely well on low, steady, and repetitive sounds such as engine hums, air conditioning units, or the consistent drone of a plane cabin. These low-frequency sounds, typically in the range of 20 Hz to around 1 kHz, have longer wavelengths and more predictable waveforms. This gives the headphones processor enough time, often mere microseconds, to accurately analyze the incoming wave and generate its precise inverse. In these optimal conditions, quality ANC headphones can reduce ambient noise by approximately 20 to 30 decibels, with some premium models achieving up to 40 to 45 decibels reduction in specific low-frequency bands. This is why ANC transformed air travel, turning a loud cabin, often around 80 to 85 decibels, into a significantly quieter space. However, the system works far worse on sudden, sharp, and unpredictable sounds like a dog barking, a door slamming, or human speech. These higher frequency sounds have shorter wavelengths and rapidly changing waveforms. By the time the microphone detects the wave, the processor analyzes it, and the speaker generates its mirror image. The sharp noise has often already spiked and passed, too quick to cancel cleanly. The processing delay, even if only a few milliseconds, means the anti-noise arrives too late to perfectly align with the original, leading to less effective cancellation. Better, more advanced headphones often use a hybrid active noise cancellation system, employing 2 or even more microphones per ear instead of just one. One, called a feed-forward microphone, is placed on the outer surface of the ear cup, listening to the world before sound even reaches the headphone cushion. This external mic acts as an early warning system, capturing noise early to allow more time for processing, and is particularly effective against consistent low-frequency sounds like engine hums, often between 100 and 300 Hz. A second feedback microphone is positioned inside the ear cup, right next to your eardrum. This inner microphone listens to the sound that actually penetrates the ear cup and reaches your ear, checking how well the cancellation has worked. This feedback loop continuously feeds information back into the system, letting it adjust its mirrored wave on the fly if the seal shifts or the noise changes, correcting itself many times every second. This dual mic hybrid approach offers the broadest frequency coverage and the most effective noise reduction, tackling both low humming sounds and some higher tones. Crucially, none of this electronic wizardry touches your music. The mirrored cancellation wave and your actual audio are generated and played completely independently, layered together in the same tiny speaker. This is why you hear your song clearly while the surrounding rumble fades into near silence around it. While the dramatic disappearance of that low engine roar is entirely software and physics working together, the physical seal of the ear cup still plays an important role. Passive noise isolation, achieved through materials like high-density foam in the ear cups, helps block higher-pitched sounds that the electronics cannot catch in time due to their rapid, unpredictable nature. This combination of active and passive noise reduction delivers the most comprehensive quiet. So that quiet was never actually silence. It was one sound wave hunting down another and erasing it on contact, a few feet from your ear, dozens of times every second, faster than you could ever notice it happening. If this kind of everyday mystery fascinates you, subscribe to How It Actually Works for more.